All right, we're going to do a few application problems that involve right triangle trigonometry. Right triangle trigonometry can be used to calculate all kinds of fun and interesting things. So these are just two examples. Let's get started. In the first example, suppose you stand 6 meters from the trunk of a tree and measure the angle of elevation from the ground to the top of the tree to be 62 degrees. How tall is the tree? Okay, so we're going to try to calculate the height of a tree. So first of all, I'm going to draw a tree. Of course, it might as well be Christmas now because it's really snowy out there, so I'm drawing kind of like a pine tree or something. So there's a tree. Suppose we stand 6 meters from the trunk of the tree. I'm going to make an assumption here, which is going to be a common assumption that I make, and that is I'm going to assume that the ground is horizontal and that the tree is vertical. Whenever we're talking about like the ground, let's always assume that it's horizontal unless otherwise stated. And if we're talking about something like a tree or the wall of a building, let's always assume that those are vertical, okay? So that means that in particular, the tree and the ground are going to form a right angle over here. Now we're standing here 6 meters from the trunk of that tree, okay? Now, let's measure the angle of elevation. An angle of elevation is an angle measured up from horizontal. So whatever like dotted line, through space or along the ground or wherever, whatever line constitutes a horizontal, you're measuring up or up for an angle of elevation. Sometimes you'll hear angle of depression, which is measuring downwards from horizontal. Okay, so the angle of elevation here is measured from the ground up to the top of the tree and to be 62 degrees. So if I draw a dotted line through the air from the ground up to the tip of the tree, that angle there, that angle is 62 degrees, right there. So with this information, the question now is, how tall is the tree? So the variable we want to solve for is the height of the tree. I'm going to use the letter h to represent that height. And that variable h could be labeled on our diagram right over here. I'm going to draw like a dotted line straight through the middle of the trunk. That is our h, okay? So the tree, the ground, and the line from the ground to the top of the tree, form a right triangle with this angle in the bottom right corner being 62 degrees. So now what I can do is I can use a trigonometric function to solve for h. Since with respect to this angle, h is the opposite side and 6 meters is the adjacent side, I want to pick a trig function, sine, cosine, or tangent. I want to pick one that involves opposite and adjacent. If you've memorized SOHCAHTOA by now, or just remember it from the previous video, opposite and adjacent are involved in the tangent function. So what I'm going to write is tangent of the angle, 62 degrees. You always give the angle as an input to your trig function. So you're never going to put like the ratio on the inside. The ratio is what the output is. So the angle, we're always doing tangent of the angle equals the side ratio, which in this case is h divided by 6 meters. So there we go. If I multiply both sides of this equation by 6 meters, it's going to cancel out, and I get h equals 6 meters times the tangent of 62 degrees. And I'll just remind you from the previous video, I mentioned that trigonometric functions, their output values are always unitless because you calculate them as a ratio of a distance divided by another distance, so the units are going to cancel out. So this is 6 meters times a number, which is going to be unitless. So this is going to be equal to some value in meters. So now to calculate what this equals, I can use a calculator. Okay, so let's pull out the handy dandy calculator. Now, right now, we're going to type into this calculator, hey, tell me what the tangent of 62 is, right? And the calculator knows how to figure that out. But we are, in later videos, I'm going to explain to you how we can begin to figure out the exact values of trig function outputs from scratch. like by hand, without necessarily relying on a calculator. Okay, but for these application problems, we're going to do the calculator. Now, before I type this in, what do I need to do? That is in degrees, right? My angle here is in degrees, so if I'm going to be typing in tangent of 62, I better tell my calculator that that angle, 62, is measured in degrees. To do that, I've got to go into mode and make sure that my setting, my angle setting here is set to degrees. It was radians, so it's a good thing I checked because I need to switch it. Now you can see it says degree up there. So now I can type this in. I'm going to type 6 times tangent of 62. My calculator is going to interpret that as 62 degrees, and then it's going to get the tangent value, multiply it by 6. And I get 11.28. So I'm going to round that to 2 decimal places. That's 11.28 meters. And that's the height of the tree. So there's the first example. Let's do another example. In this second one, we have a 12-foot ladder, which is leaning against a house, and it forms an angle of 50 degrees with the ground. How far up the house does the ladder reach? Well, let's draw a picture. Here's the house. Okay. Windows up here. Boop, boop. Okay, there's a door down here. Okay, and here's the ground. So there's a house and there's the ground. The ladder is on the outside over here, and the ladder is leaning up against the house. So let's draw a ladder. Okay, and the ladder is forming an angle with the ground. That would be this angle right here. And that angle, it says, is 50 degrees. 50 degrees. And then since we're assuming, as always, that the ground is flat, horizontal, and that the house is vertical, then this angle between the house and the ground is a 90-degree angle. So what we want to know is how far up the house does the ladder reach, right? So that would be this distance from ground up to the top of the ladder along that side of the triangle over there. So that is going to be, again, I'll use h for height. You can use whatever variable you want. If you want to call that x, that would be just fine. Now there's one more piece of information that I didn't put in this diagram, and that's the length of the ladder. The length of the ladder is 12 feet, given in the problem. So now take a look. We said a 12-foot ladder leaning against a house, there we go, forming an angle of 50 degrees with the ground. There's the angle with the ground. How far up the house, this distance h, does the ladder reach? So we want to solve for h. Again, we're going to use a trigonometric function, but this time, from the perspective of that angle that we know, the 50-degree angle, the opposite side is h, and 12 feet is the hypotenuse. So we want to know opposite, and we know the hypotenuse. What function involves opposite and hypotenuse? From SOHCAHTOA, you can figure out we want to be working with sine. So sine of the angle, 50 degrees, is going to equal the opposite side, h, divided by the hypotenuse side, 12 feet. Just like the previous problem, multiply both sides by 12 feet, cancel it out over here, and we get h is 12 feet times the sine of 50 degrees. And we can pull out the calculator. I've already got it set to degree mode, so I'm just going to do 12 times the sine, nope, that's cosine, times the sine of 50 degrees. And that is 9.19. I'll round that to about 9.2. 9.2 feet. And that's how far up the house the ladder reaches. So there's a couple examples of using different trig functions, one tangent, one sine. Sometimes you got to use cosine. Which trig function you use for the problem all depends on which sides of the triangle you either know or want to know. Okay, so like in this first example, because we were not given any information about the hypotenuse length, and we also are not being asked to calculate the hypotenuse length, we specifically avoid using any trig function that involves the hypotenuse length, right? And then similarly for the second example, we didn't know anything about this adjacent side, and we weren't asking for the adjacent side, so we specifically chose a trig function that doesn't use the adjacent side. So that kind of logic, I want you to think along those terms when choosing which trig function to use for a problem.